Piet Boer. I was the project architect on Soccer City. I've been involved in the project from about 2006, where we start with the design and followed it through until you see the final built product that is there today. I'm also one of the partners in Boogertman and Partners, a fairly big architectural firm in South Africa. Well, we've been involved with the old FNB stadium for quite a few years. My personal involvement was essentially from 2006, from when we won the bid for the 2010 World Cup. And at that stage we started with 10 different designs of the stadium to almost try and place an iconic stadium there on request of the city and on request of the government. So we went about a whole process of designing these 10 different ideas, or developing 10 different ideas for what the stadium could possibly be. And it varied from various concepts of the Protea or the bowl or the mine dumps, all aspects of Africa or Southern Africa or even Johannesburg that gets incorporated into the stadium, and in an attempt to place an icon there that everybody can relate to. And when we presented the 10 different ideas to Danny Jordan, his immediate option was for the African pot as the most recognizable icon for the whole of Africa, as a unifying element and as something that everybody can share in. And from there, which was at that stage a very, very basic idea, we developed it to what you see there today. Our tender process, we've been involved in the stadium from about 2000, where we've done various options on what the stadium could be at that stage, how it could be upgraded for a bigger capacity, and how it could be bettered to get better sightlines, to get better functionality in terms of services and all of that. And we were also involved in the designs that we included in the bid books, the first bid book for the 2006 World Cup, and then the bid book for the 2010 World Cup, which is finally the one that we won. So after South Africa was awarded the World Cup, our appointment was essentially extended from all the work that we have previously did for the stadium, and it was formalized on that basis. We worked on risk from 2000 till after we started building on site. So until then, there was no fees ever earned. It was on a risk basis, and we were appointed effectively after the contractor. The stadium was built on a JBCC contract with a few addendums to it, but it was the standard JBCC agreement, which works for the South African environment very well. We had quite a few international contractors as well, which had to be educated essentially on how the JBCC works, and especially in the local environment of how you deal with subcontractors and where the design responsibilities lie, because it's fairly different from the process they would follow, let's say, in Europe. Because the time frame that we had to design and develop the stadium was so extremely limited, we had to work very, very closely with the structural engineers and the mechanical and electrical and the entire team to develop the stadium as a unit. So it's not just an architectural solution where we went out, decided what needs to happen, and then everybody needs to implement their systems. It's a cohesive, holistic approach that we followed, where everybody was part of the process to develop the stadium and to make it as cost effective as possible. So we worked very closely, firstly with Hans Korn of PDNA and Frank Simon of Boogertman and Partners in Germany, to develop a structure that incorporates our idea of what this African pot should be, with a minimum of structure that you have to place there, and it just becomes part of this pot that we created. So it's one thing. It's not one thing supported by another thing. It's a unit. And the same goes for all the other systems that we introduced into the building. It's all linked together very well, which is quite fortunate. It's got a lot of memory to the old stadium. So what we did in the design is we kept as much as we possibly could, which effectively in the end was the piling structures all the way around the stadium, and the western stand we managed to keep 3 of the slabs and the columns that was there. Unfortunately, the rest of the stadium was not really usable, so we had to redo the embankments, we had to redo the upper tier on the western side, and all the services and everything else we had to essentially take out and do away with and install new. What it did do, however, is it gave us the opportunity to keep some of the memory of the old stadium. So we painted all of the old aspects of the stadium a dark grey colour as part of the memory, so one can always see what the stadium was and what's left over of the original, and it's still in the same position. In retrospect, I think it would have been more cost effective to build a new stadium next door, because you can work with much better efficiencies. You can have different spans, less columns, your precast could be completely different modules, your dynamic loads would be different, and you can wrap the stadium much tighter around the pitch, so you reduce the amount of facade area and reduce the amount of roof. But because the stadium has so much memory, I think it's the right decision to upgrade what was there to what we've got now. And the other important thing is, because this is in the piece of land that sits in between the CBD of Johannesburg and Soweto, and which was essentially no man's land previously, this now acts as a very good catalyst for that area to develop and to link the city and Soweto as a unit again. As part of the vehicular access, the old FNB stadium was already built on the intersection of what's essentially the M2 and the N1 Western Bypass, so it's very well connected in that sense. But to get from those two highways to the stadium was a bit difficult, because you could only take Rancho Road or the Nasrec off-ramp. So additional off-ramp was built, which is an extension of the N17 highway, which in future will be extended all the way through. But from the N1 you've got this additional off-ramp that's introduced, which gives much better vehicular access. And there's numerous roads built around the stadium, including the Golden Highway, which is a link between Rancho Road at the moment and the N17, which gives you much better accessibility to the Nasrec precinct or the Nasrec arena. We also built a whole transport hub which can incorporate, or does incorporate, buses. It incorporates bus rapid transport and taxis. And then there's a station facility as well for the Metro Rail, which is an existing station that was upgraded and is linked into the transport hub that we built. And on the northern side of the stadium, there's an additional BRT station that was built. So we can accommodate about 75% of the people that come to the stadium with public transport quite easily within the 2 hours before a match. And that equates to about 70,000 people that you bring in with public transport, which is quite efficient, and that's not with the additional park and rides that can be introduced as and when required. For the stadium itself, to get into the stadium is one thing and one can design for it, but the biggest risk is to get people out of the stadium in case of emergency. So in terms of regulations, you need to get to a place of safety within 8 minutes. So the entire stadium is designed on an evacuation basis so that you can get every person to a place of safety within 8 minutes, which on the lower embankments mean that you need to get them out up to the pit of fire, which is the security line around the stadium. And for the upper tier, it means you need to get out from the upper tier to the ramp structures, which essentially sits away from any risk that might be there. And so far from all the tests, it seems that it's been working very well. For ingress, your biggest queuing distance is in terms of the turnstiles and where people come from, because you've got most of the people with public transport coming from the south, from the transport hub and over the promenade. We've got a lot more turnstiles installed on that side, but you can also access the stadium all the way around. So we've got movement paths all the way around the stadium so that you can access any side of the stadium that you might need to. So if your seats are on the north and you arrive at the south, you can move around the outside, or you can go through the turnstiles on the southern side and move around the stadium on the inside within the secure perimeter. So it makes the whole stadium much more accessible. We've also got about 26 entrances on lower concourse level, and then 8 ramps that can take you up to the upper levels of the stadium. Part of the old stadium used to incorporate incorporate an old moat, which was a security feature that was designed, and it was seen as a good security measure to prevent people from getting onto the pitch previously. Nowadays that's frowned upon. So what we did is we enclosed the entire moat with a slab and waterproofed the entire inside to create a big water reservoir where we can save about 3.5 million litres of water, which we can then use to irrigate the pitch, which takes about 100,000 litres a day, or we can use it to flush the ablutions on the lower concourse level, so for embankment concourse and lower concourse. So it's just saving as much water as you possibly can. So we're collecting all the water that falls in the roof opening, so whatever falls onto the pitch or into the bowl, and then about 3/4 of the water that falls onto the roof gets collected and tunneled into the moat itself. And then for the rest of the grounds, we've got attenuation ponds on the northern side, which can collect most of the water. It's got permanent water in it as well, so that you create a bit of a wetland ecosystem there to essentially control the amount of water that would fall into the normal sewer lines. We followed the green goal as set out by FIFA as one of the requirements, and that deals with a few aspects. So it's waste, it's energy, it's transport. There's quite a few, I can't remember all of them. So in terms of transport, we looked at it definitely in terms of the public transport, and how we get people to the stadium and away, back from the stadium again. In terms of waste, we've got a whole waste methodology of how you collect waste within the stadium, how you can separate it. We've got compactors on site, we've got sorting tables on site. We can split between dry waste and wet waste and just try and recycle as much as possible. In terms of the building itself, we also crushed all of the existing bricks on site, or not all of them, we crushed all the existing paving on site to use in the layer work, so we had to cart in less material to site. The existing bricks was cleaned on site and made available to the local community. We tried to reuse all the components of the old stadium within the stadium layer works, or within components of the stadium as well. Even excavated soil, we tried to use as much of it on site, to just creating berms and features rather than carting everything away. In terms of energy, I think we've been fairly efficient. We've got energy efficient lights throughout the stadium, so all the concourses has compact fluorescent lights, the outside areas. The main stadium lights works on a building management system where you can adjust them according to the television requirements that are there for a specific match. So if you've got high def television, then you need 2000 lux across the entire pitch. If it's normal television, then you need 1500 lux. So you can adjust the light levels accordingly and reduce the amount of energy that you effectively use. We try to recycle as much water as we possibly can, as mentioned earlier. And then in terms of materials, the facade is made of a fibre reinforced concrete panel, which has a life expectancy of about 60 years. It's colour through, it's got no maintenance requirements whatsoever. And it can be fully recycled after the stadium is decommissioned. The structure for the roof is all steel, which is completely recyclable, and then the concrete, although it's more difficult to recycle because of the steel content in there, it can still be reused in certain instances. Well, interestingly enough, some of the bigger loads on the stadium is wind loads, and the stadium trying to be sucked out of the ground. So we did extensive wind tunnel testing in a small town called Kobbelmoor in Germany, where they built a whole model, and through the wind tunnel testing we could calculate what the forces on each side of the stadium would be. And what we realized is that I think it's about a 500-ton uplift per core. We've got 12 cores around the stadium that is generated. So we had to introduce tension piles for the main roof supports that go down 30 meters to the bedrock, and then another cables that are grouted in another 8 meters into the bedrock below. And those cables would go all the way back into the roof structure to keep the entire stadium down, which was quite an interesting feat. The outside structure is essentially split into 3 sections, or 4 sections. So the first section from the ground to upper tier level or upper concourse level is a concrete structure, and that acts as a cage around the whole stadium. There's steel tie beams that sit in between every concrete column, and that acts as a cage, holding the whole stadium together. That's made in concrete because all our ramps are suspended from there, and it becomes the link between the outside face of the pot and the existing stadium structure. So you've got that dialogue of the two structures that has to take place, and concrete was the logical choice in terms of program and just in terms of how the structural systems would work. Because in sections you've got ramps connected into it, in sections you've got normal suspended slabs connected to the facade itself. So from the upper tier or upper concourse up, it's a very simple steel structure, which is essentially a steel cage again. It's 400 by 400 8 sections that go all the way to a spatial ring truss, which sits around the stadium, and it's connected at top and bottom with pivot connections, so it can move independently from the rest of the structure. At the top, it's supported by the spatial ring truss, which is the main structural element of the roof. It's about 800 meters long. It's a big triangular space frame that supports the 37-meter cantilever on the one side and the facade on the other side, and takes up all the wind loads. It takes up the weight of the whole structure of 7,800 tons of steel in the roof itself, and it transfers it to 12 columns or 12 structural shafts around the stadium. And those are the same shafts that will deal with load and with wind load in certain instances as well.
My name is Hans Korn. I'm a director of PDNA and Associates, consulting engineers. We were in the fortunate position that we were appointed as principal structural engineers on the Soccer City Stadium. We appointed as our sub-consultants a company by the name of Boogertman and Partners, a German company who are specialist structural steel and facade specialists. We appointed them to assist us with the design of the roof and the facade structures. Soccer City was obviously a very complicated structure to deal with. We dealt with an existing pavilion which had limitations in load-bearing capacity. We therefore had to strengthen some of the existing parts of the existing pavilion. The existing pavilion was retained for various reasons, one of them being historical reasons, and at that stage, in the initial parts of the contract, everyone believed that we would save money by retaining the existing pavilion. This, however, proved not to be so. I think it would have been cheaper to demolish it and rebuild it. So we had to deal with massive forces which are generated from dead load, obviously, and live load on the pavilion structures, as well as wind loads. The facade structure attracts a lot of wind load, and some of it is obviously uplift in certain conditions, certain load combinations, and all these loads in different combinations had to be catered for and obviously transferred safely into the foundations. Some of the foundations attracted uplift forces of 5,800 kilonewtons and downward compressive forces of 10,000 kilonewtons, massive forces that we had to deal with in very, very large moments. And due to varying soil conditions on site, we had various founding options which we adapted as these became apparent. To deal with the uplift forces on the foundations, we had to put in tension piles. Some of these piles in certain cases went down 33 meters into the ground, and then there were still divvy-dag bars that were delved further 6 meters into rock. Some of the piles were 1.5 meters in diameter. Another big challenge on the project was the facade columns. There are 120 facade columns which are constructed around the stadium. These facade columns take all the facade vertical and horizontal loads, as well as obviously the wind loads as well, and they are eccentric to the base. The top of the facade column is about 17 meters above the base, and horizontally about 6.5 meters away from the base. which obviously in its static state attracts huge moments and once again uplift in the foundations. These facade columns also proved to be a challenge to construct because of the very large content of reinforcing steel in the columns. If my memory serves me correctly, I think there was about 800 kilograms per cubic meter of reinforcement in these columns, which obviously made it very difficult to compact the columns with normal poker vibration. The contractor, which is Grinneker LTA Interbeton joint venture, opted to use self-compacting concrete. The concrete strengths in these columns after 3 days was approximately 40 MPa, very, very high strength concrete and very durable as well. Another big challenge on the project was the design of the shafts. The entire roof structure is supported on 12 large shafts. These shafts vary in plan dimension, and once again they attract all the horizontal vertical loads from the roof, and these are then taken down into the foundations, which I described earlier, which has got tension and compression piles. The shaft walls were on average about 500 to 600 millimeters thick. Also very dense reinforcement, I think up to 450 kilograms a cubic meter. And the compaction of these walls was also a challenge for the contractor, but in the end the quality that was obtained was of a very high standard. The existing pavilion between Boogertman Urban Edge Architects and ourselves, it was agreed that the sightlines had to be improved. A very detailed investigation of the sightlines was undertaken by the architects, and it was decided that the existing pavilion on the western side, the sightlines had to be improved, and therefore we removed all the precast seating elements on the upper tier, improved the rake of the existing pavilion, and put new precast seating elements onto the structure. It was also found with detailed surveys, which only became apparent after the contractor had started on site, that there were many discrepancies on the existing pavilion which had to be dealt with. The new structure in relation to the old structure, we discovered that there was a rotation. So during the construction stages, and this was unfortunately not picked up before construction started, but it resulted in us having to design transfer beams to ensure that the rotation was dealt with. And we furthermore picked up that the existing pavilion was not level, and therefore leveling screeds had to be introduced. These leveling screeds attracted a lot of additional load once again, so the existing structure also had to be checked and made sure that all the existing load could be catered for. And in fact, there was quite a bit of strengthening required on the existing pavilion. We used quite a bit of carbodur strips as supplied by Sika, which efficiently dealt with tension zones in the concrete where we couldn't introduce additional reinforcement. We also did quite a few load tests on the existing piles. Quality control on the stadium we found to be extremely important, and we did numerous tests. I believe at Soccer City we probably did more tests than any of the other stadiums. These included static and dynamic load tests on the seating elements, and we wanted to ensure that the seating elements would have a natural frequency higher than 6 Hertz as recommended by the Green Guide. These were undertaken at Wits University in the laboratory, and we found that on average the natural frequencies were about 12 Hertz, so well above what the minimum requirement was. We did, as I said, we did quite a few static load tests as well on the seating elements. The design static load was 500 kilograms per square meter, as required by the code, and these elements failed in the region of 4,000 kilograms a square meter, so well above the design load, and they are extremely slender. These elements were about 80 millimeters thick on the horizontal element, but the strength and the transferring of loads is obviously via the vertical element, which was about 100 millimeters thick. The spans in general varied. They were quite small. They varied between 5.3 meters to probably 6.5 meters, if I remember correctly. We also did, to ensure that everything complied with the green guide, we did a lot of horizontal load testing on the walls, on balustrades. We did load testing, tension load testing on piles. We obviously couldn't simulate the large forces that were required because there's just no equipment available to do that. But Wits University once again assisted us with that, and we did dowel tests in rock to ensure that the dowels could transmit the loads that we required. Compressive tests were also done. We also did load tests on the existing slabs, and all of these tests passed, which obviously gives a lot of comfort, and we knew that the stadium would be durable and would be able to accommodate all the loads that it was designed for. And I think after the successful World Cup at South Africa hosted, it's evidenced that all the stadiums in South Africa were designed properly.
Okay, the lifts are, for lack of a better word, in the corners of the stadium, even though it's a round structure, but the bowl is fairly square. So most of the lifts are positioned in the corners, part of a circulation core where you can get up and down from the lower concourse to the suite levels and to the upper concourse as well. And each corner we've got two lifts, one for public access or for suite owners and for people that would access the upper concourse level. And the second lift is for maintenance and for serviceability of the stadium. And that one would act as a fireman's lift as well. So these lift structures with the staircase in between them became fairly structural components that kept the stadium upright as well. So it's very nice stiff elements that one could place there, and it allowed us to give numerous flexibility in the way the stadium could be accessed, and it just reduced the distances for somebody to get to a specific suite. So those work fairly well. We've also got two lifts that link the lower basement level with all the other levels, and especially with the hospitality area on the upper concourse western side. And in the basement, it links directly to the main kitchen of the stadium. So it allows additional flexibility of the stadium to be used for other events, for instance, weddings, conferences, all sorts of other events that is enabled because you've got this connectivity from the main services or the main kitchen in the stadium. The western side also has two lifts just to service the VVIP and VIP levels of the stadium to the basement. In terms of the budget, the final construction value of the stadium was 3.38 billion rand, which is extremely cost effective still. I mean, it's much more than what the original budget for the stadium was, but it is, when you count it or calculate it as cost per seat, it's one of the most cost effective stadiums in the world, especially of a stadium this size, because the costs go up exponentially the bigger the stadium gets, because your cantilevers become bigger, your areas around the stadium just become so much bigger to cope with the tremendous amount of people that you've got. So it definitely was a cost-effective stadium. The original tender value was 1.916 billion, and so there's been quite a bit of creep from there. But it's not as if the design changed anywhere through the process. That was the basic build contract, but all the other components got added as we went along. And unfortunately, it was in the big rise of the construction industry still, so costs did escalate quite a bit. The design scope, however, didn't really change that much. There was quite a few items that we incorporated as part of the FIFA requirements, but yeah, essentially the scope stayed the same. It was value that changed. In terms of suppliers, what was quite interesting, and it's the first time we've ever dealt with it on such a scale, is that you could actually access the international market for products at more cost-effective rates than locally because of the volumes. The local industry wasn't necessarily geared to deal with volumes of that nature, so you could go to the international market, and because their systems are set up in such a way, you could get similar materials or even better materials at much lesser cost. In terms of experience, in South Africa we don't have the luxury to specialize in a specific field like you might have in Europe. So we're masters of all trades in the architectural profession within our firm. And if something like the stadium comes across our path, you have to go on a learning curve. And it was a massive learning curve to learn how to build and develop a stadium like this, and to make sure that you comply to all the international regulation. So between myself and my partner Bob van Beber, we went through this learning curve and just made sure that we know what all the requirements of a stadium is. And we also contracted with a company called HOK at that stage. They're Populous now, to assist us on a technical basis and to make sure that we comply to all the international regulations related to sports and events venues. So they came down about once a month and checked all our drawings, made sure we comply to the British standards, to the Green Guide, which was quite an important guide for us in terms of design, and to any other regulations that there might be, or just good practice that there might be. But otherwise, it was us and our team, and we had to learn. We had a very small core team of people, very senior people within our office that dealt with the project, specifically because with the time frames, you don't want to go and manage 50 people or 30 people or whatever. So we kept it as small as possible with the most experienced people that we had available in our office to develop this thing to what it is today. And if we had to have more people, then suddenly you've got more management. You actually start losing efficiency in the process. So our motto was to keep it as small and tight-knit as possible and just make sure it gets done correctly the first time round.
One of the biggest lessons learned on this project, well, there's a few lessons learned. From the start, I think we weren't afforded enough time to do all our designs and investigations. The wind tunnel testing was commissioned at a very late stage. In fact, it was commissioned a month before the contractor moved into site. So a lot of the forces for which we had to design only became apparent once the contractor was in site, which made everything quite a challenge, obviously, to ensure that everything was catered for properly. Another big lesson learnt, and these things are always very easy to discuss retrospectively. It was impossible to have known this initially, but it probably would have been easier, cheaper, quicker to have demolished the existing grandstand. We picked up quite a few problems and challenges, and I think a couple of delays and also budget jumps due to us having retained the existing structure. We managed it, but it took a lot of man hours within the company, and I think a couple of divorces were looming the way we carried on. Fortunately, we all survived, and we've got a fantastic project. A huge portion of the project's success was certainly the very, very good teamwork between primarily the architects, Boogertman, Urban Edge and Partners, ourselves as structural engineers, PDNA and Associates, and then also the contractor, Grenike LTA Interbeton. We had a very good working relationship from the very beginning, and we had technical meetings every single Monday at the architects' offices, in which we dealt future challenges on the project and made sure that these were dealt with on time. And then on Thursdays we had technical meetings every single Thursday on site as well, and this is where we addressed current issues on site and challenges. It was a great working relationship, and I think if it wasn't for that, this project wouldn't have been a success as it was.
As a whole, I think the process was actually quite rewarding, because you build friendships and you build relationships with people because you work so tightly together with them for 4 years that, I think it's friendships that will last. What was also quite nice is that for the first time we worked with international contractors on such a close-knit basis, and for them it was an interesting experience of how the South African market works, where it's not just about litigation. You actually go out there to make a plan, to develop this thing together and to get it built, because the contractor that has to build it must have as much say in it as the engineer and the architect and everybody else to get to the right solution in the end of the day. And I think that's one of the nice elements of a project like that, is that everybody in the team could be involved in such a way that they became part of the process. I'll do it faster, because now I know how to. The one thing I would probably change is, and I won't elaborate on it too much, but we'll require appointments to be directly to the city who is effectively outlined. Contractually, make sure that all your contracts are drafted by a lawyer beforehand, and don't try and do it yourself, because that's just dangerous. It gets you in a lot of hot water. From a money perspective, I mean, it's a big project, there's big money involved in it. It's just managing the process correctly. But the risks are also huge involved in a process like this, because you make one small mistake and it gets repeated 20,000 times. One bolt that's specified wrong and you've got 50,000 bolts on site that can't be used. So you have to be meticulous in whatever you do, contractually and in the implementation of everything. It has to be meticulous all the way through. So that's probably the most critical item in building a big structure. Fortunately, South Africa is not as legally inclined as the rest of the world initially in a project. I think in the end we end up in the same way, so it's the same lawsuits and everything else. But initially you can work together in a very good way to get a very good product out there very quickly. Whereas internationally, I think it takes a bit more of your time to deal with all the legal aspects in the initial phases, when you should actually focus on getting the design out and getting the building built. Yeah, I think in terms of what the design is in the end, I don't think we'll change anything. I think the product that is there has become what it's supposed to be. It's one of the icons of Africa and the icon of South Africa, and definitely one of the key elements of the World Cup. And I think everybody of Johannesburg especially, and probably South Africa, has taken ownership of what the stadium is, and that's what we really set out to do. So in terms of efficiencies, I think we can program it differently, we can document the building differently, and we'll probably implement different systems which we didn't have the luxury to do when we started with the project. But yeah, I think it's all about efficiencies. We can do it quicker and faster and better this time around. But in terms of the communication with the contractor and with, for instance, the structural engineers, I think that was very good and worked very well. The stadium was definitely designed as a business that has to work for 7 days a week. It can't just rely on events to support itself. So that's why we incorporated office space that could be leased out. You've got all the additional areas around the stadium that could be used for the weddings and funerals and everything else, and for additional sporting events. The entire site is reticulated with IT and with power, so you can have big markets, or you can have truck launches or mini launches or whatever. So there's a multitude of aspects that you can bring into the functioning of the stadium and into the feasibility. And currently, it's the only stadium that hasn't asked the government for additional money to support itself, because it's got that model of working as a 7-day-a-week business, and they are implementing it that way, and they are running it in that way at the moment. So it is managing to maintain itself. It will never be able to pay for itself, not in the South African market, but it will be able to pay for any upgrades that's required or any maintenance requirements that is there, and yeah, it will still make a profit for the city, even though it is being a small profit, but it's not a liability around all of the people of Johannesburg's necks, which I think was very important for us, because you don't want to build this big white elephant that everybody frowns upon afterwards. People need to take ownership of it and appreciate what's there, and it needs to support itself in that sense.